Hi, welcome to the sixth session of Algebra 1. My name is Shovik and I'm a scholar of item address and my supervisor is Dr. Ramesh Kashi. So, today is in this live session, we will start with some exercises from permutation book. Okay, so sorry. First we'll go through some easy examples of permutation group, then gradually we'll increase the difficulty level of this thing. Okay. So, mm, oh, so first question is one second. Okay, done. Now this one. Okay, so first question is hello, am I audible?
Yes,
Okay, can you see the screen?
yes, it's visible.
Okay, fine. Okay, so before starting anything, please let me know. Do you have any question? Okay, so let me repeat that today we shall start with some basic problems of permutation group. But before starting, let me know if you have any doubts or any questions.
ক্লাস করছি পরে কথা বলছি ক্লাস করছি পরে কথা বলছি
Mute your mic.
দাঁড়াও একবার হ্যাঁ আচ্ছা আচ্ছা
So, if you have any question or any doubts, please ask me, or else we can start some basic problems from permutation group. Do anybody have any question?
হ্যালো স্যার
Yeah, yeah.
আর ইউ প্রেজেন্টিং permutation group today?
Yeah, some problems regarding that.
Okay, that's fine.
Anybody have any question or any doubt? Please ask. So it seems no more question anyway. So okay, let's start with some basic problems permutation. So consider S4. Okay, tell me how many cycles are there in S4 due to disjoint cycles. So first question is in S4 how many 2 to disjoint cycles are there in S4? This is the first question. Like I mean it will go the form both. So how many 2 to disjoint cycles are in S4? Let's think about it. I mean I know it's easy but you should those who don't know let's try. It's a basic permutation problem that we already started with the first 11 or 12. Okay, so think it in that way. Anybody any idea? At least how to do it? Any idea? Don't hesitate. Please tell if you have any idea of solving this problem. Do you have any idea? Anybody? Don't be silent. If you have an idea, please let me know. Okay, so the idea is as follows. Since we need to get a 2-2 cycle, okay. So first portion can be filled up in 4 ways, okay. Second portion can be filled up in 3 ways, okay. Now the thing is, observe that the cycle AB and the cycle BA are both same, correct? So that's why first we need to divide by 2 into. For this third portion, we have only two choices left, two, and obviously for the fourth one we have only one choice left. Similarly, divided by 2 into. Now this is a one disjoint cycle. This is another disjoint cycle. So disjoint cycle commute. So I mean ABCD is equal to CDEAB. Okay, disjoint cycle commute. So we need to multiply it by half. So that is how it comes up. 2 2. So it is only 3. So there are only 4 3 2 cycles in S4. Do you understand the way of doing it? Do you understand the way of doing it?
Sir, in the first case where we have four choices we have element 4 factorial. We have element S4 has element 4 factorial.
Yes, right, correct.
Um, While four choice, rest of the argument, all right. After that, three to divided by half. That is also clear. But first choice, why four?
First choice can be free. I mean, 4 S4 4 factorial means there are 4 factorial number of cycles. I mean, the total number of elements is 4. But in each box, the number will be either 1 or 2 or 3 or 4, right? In each box can
Oh,
fill.
okay. Sorry, I am sorry.
Yeah. So S4 has 2 cycles order. Okay. So odd number of cycle is 3. So does everyone understand this? If you have any issue with the counting argument, please ask. I will again explain this. If you have any counting issue argument, please ask. I will again give the argument.
You can proceed. Oh, clear.
Okay. So the next question is that how many elements of order are in S4? How many elements of order 2 are in S4?
Sir, order to imply the length of the cycle should be 2.
Yeah, but it is cycle. I mean, if it is a 2 cycle, then it will be
Oh,
always.
three
Yes, so
cycle will include.
yes, so you need to consider all possible choices, right? So take your time, think about it. So you need to consider 2 cycles, you need to consider may consider 3 cycles, you need to consider 2 cycles also, right? So take your time, think about it. All consider all possible situations. I mean, yeah.
Sir, in S4, what is the maximum length of the cycle?
Think about it. Right. Take it first. Think about it. Then whatever you got out, but just tell. But just completely think about it. I mean, this question is very easy, but
Hmm.
think about it. Okay.
Okay.
Is it 9?
Okay. Once again, let me calculate it actually. Just hold on. Yeah, right, correct. Very nice. It's nice. So, how you calculated it?
The number of single two cycle, number of elements with two cycle, like only single cycle is 6. That is, how I got the answer is 4 into 3 divided by 2. And then the number of elements with two cycles is 3. So total is 9.
Perfectly fine. Perfectly fine. Right. What about others? Does other get the problem? Get the solution? What about others? Does others get the solution? So okay, so let me explain the other one. So what she has said, first we need to consider two cycle, and then we only need to consider two cycles. Okay. So two cycle number of how many two cycles there? 4 into 3 by 2. Plus how many two cycles there? 4 into 3 by 2 into 2 into 1 by 2 into half. So it is 6 plus 3 is equal to 9. So there are 9 elements in S4 of order. Okay. Now, tell me. So, it is a one fact, and I think most of you know this. But anyway, it's good to recall the fact first. The thing is, any two elements in Sn are conjugate if and only they are of same cycle type. So fact is any two elements of Sn are conjugate if and only they are of same cycle type. So first of all, tell me, do you know what does it mean by conjugacy? Do you know what does it mean by conjugacy? I mean, if anyone don't know the conjugacy, please ask. Okay, I will assume that you know the meaning of conjugacy. So the thing is, this
No, oh,
sorry.
I don't know.
So two elements A and B are said to be conjugate to each other if there is some C in that, obviously in that group, such that A is equal to C inverse BC. Okay, so that's what I mean the conjugacy. Understand? So the
Okay.
statement tells that in Sn two elements conjugate if and only they are of same cycle type. So this means, suppose we have one cycle AB, so then any element of Sn of the same form, that is ABs are two cycles, so any two cycles are conjugate. Same cycle type. For example, two cycle means like this, right? So two cycles are conjugate of the elements which are two cycles. Sorry, two cycles. Okay, so same element, I mean, same type of cycles are conjugate to each other. That's the statement. That's the thing what the fact is saying. Okay, so yeah, so using this, solve this. So how many conjugates are there of the element cycle 1 to 3 in S4? So in S4, how many conjugates of the cycle 1 to 3 is there? Okay, please think about it. I shall get back to some minutes. So anybody can solve it. I mean, anybody got the answer? I mean, this is nothing but just application of the previous fact that any two elements in SN are conjugate if and all of the same cycle type. Okay. So now think how to calculate number of conjugates in 1, 2, 3 in S4.
I think it is 8.
Okay. Uh, so how to calculate it?
Fixing one element,
Yeah. Okay. Hmm.
then there will be two possibilities in which we can permute these elements.
Okay.
So there are, there are four such possibilities to fix, like fixing 1, then fixing 2, fixing 3, and 4. So that
Yes.
is how I calculated it.
Okay. So that, I mean, you have not used the previous fact, right? Correct. I mean, so
Uh,
nothing. No. Okay. So first, tell me one thing that how you I mean how your or how you get guarantee that the way you have calculated it is actually the collection of all possible conjugates of 1 to 3, because the conjugate means some C inverse 1 to 3 C, right? So how you
yeah,
or
but
your
we know that conjugates like cycles. Um, s- if it is of same cycle type, then they are conjugates.
yes, so basically you have
That
calculated
way,
number of 3 cycles in S4, correct?
yes.
Okay, but then but then while telling the argument, you are saying something fixing one element. So can you please split the argument then?
So I just fixed 4 and then permuted 1, 2, 3.
Yes,
So that way there are two possibilities.
yes.
So then I just fixed 3 and permuted 1, 2, 4.
Oh yeah, yeah, yeah. Sorry, sorry. I understand. Yeah, you have that's very perfect. Yeah, very nice. Sorry. So, mm, okay. So what about others? Okay, so I think other folks. Oh, sorry. Okay. So the next question as follows: that mm, so we all know A4, right? The event permutation collection. Event permutations in S4, right? And so what is order of A4? Order of A4 is 12. So uh, um, okay. So hmm. Okay. So tell me why A4 can have subgroup of order 6. So why A4 can't have subgroup order 6? I mean, yeah. I mean, the thing is, it is not obviously, it is not directly connected related with till now what I've done. It is not related with counting argument. Okay, it's it's a purely group theory problem now. Okay, now think about it. Why it can't have any subgroup order 6? Only a group theory argument will work. Nothing, no extra argument. Think about it. you get any rough idea. Anybody got any argument or any rough idea at least? Okay, so the idea goes as follows. So let h be a subgroup of F4 order of h equal to 6. Okay. So first tell me how many uh, two cycles are there in F4. So number of two cycle is how many two cycles? Is 8, right? I mean how many two cycles is sorry in F4. F4 means yeah. Sorry, it's not two cycle. How many two cycles in F4? So this 3. Okay. So three two cycles are there. Okay. And how many 3 cycle are there in F4? Because 3 cycle is nothing but can be written as it's a transposition. Okay. So 3 cycle is element of A4. So how many 3 cycles there? 3 cycles is 4, 3, 2 by 3. 8 3 cycles are there in A4. Okay. Now if order of h equal to 6, so there exists at least one 3 cycle alpha. Does that alpha does not belongs to h, right? Now so alpha is 3 cycles, so alpha square So alpha cube is identical with this simple alpha square is equal to alpha inverse. Okay. Now, since H is subgroup, so this implies or alpha inverse does not belong to capital H. Okay. So this implies alpha square does not belong to H. Okay. So we can consider another subgroup K, whose elements are 1, alpha square. Okay. And H is also a different subgroup. Now, what is the order of H? Order of H is equal to order of H into order of K by order of H intersection. Okay. Now, order of H equal to 6, order of K equal to 3, and intersection has no element, so 1. Okay. So 18. So the order of HK is 18. So if it has a subset contains 18 elements. So there is a contradiction, right? So that's why F4 can't have a subgroup of order 6. So this is the argument. Do you understand? Tell me, do you understand? Or please go through the argument once again. Okay, so let me reveal the argument first. So we have initially we assume that it has a one subgroup order 4. Okay. So order 6. Now F4 contains event permutation. So how many 3 cycles are there? There are 8 3 cycles. Okay. But the order of H equal to 6, so it can't contain all 3 cycles. So let alpha be on one 3 cycle which does not belong to H. Okay. So let alpha cube be equal to identity. So this implies alpha. Now alpha is 3 cycles, alpha cube identity. This implies alpha inverse does not belong to H. And this implies alpha square equal to alpha inverse, and alpha square does not belong to H. Now consider subgroup K, which is equal to 1 alpha square, and HK is equal to 6 into 3. So order of HK is equal to 18. So G has a subset of 18 elements. So that's the contradiction, right? Do you understand? Do you understand the argument? Please let me know. Do you understand the argument?
Yes, yes.
Okay, so go to the next problem. So, how many elements of order 10 are there? So in S7, how many elements of order 10 in S7? Think about it.
maximum cycle length is 7, right?
Yes, yes.
Then order 10, is it possible?
Yes. So you can consider the situation that if we have a cycle like sigma 1 compose sigma 2 compose sigma 3 dot dot dot, then the element of this composition is the LCM of the order of the composition is the LCM of order of sigma 1, order of sigma 2, order of sigma 3 dot dot dot. Okay, only this way can give you
Okay,
the
okay.
element order.
Correct.
Yeah,
Got it.
yeah, yeah. So tell me how many element order, think about it. Okay, first 10. Okay, so there is no 10 cycle, firstly. Okay. And 8 2 cannot be possible also because there are only 7. So only possibility is uh, sorry 10 cycle. So factors are 10 1 1 10, sorry 2 5 5 2. Okay. Only this way we can get 10, right? So that is we need to take how many 5 cycle, I mean how many 5 2 cycles are in S4, right? This is what we need to check. So how many 5 cycles are there? That is 1 2 3 4 5 1 2. Okay, so how many 5 cycles are there? 7 6 5 4, 3 by 5 because 5 cycles, so we can, so in 5 is, I mean, if ABC, this is same as BCA, this is same as CAB. So in this way, any 5 cell can be written immediately in 5 ways. Okay. So multiplied by 2 into 1 for 2 cycle by 2 into 2. Okay. So 2 2. Okay, and this thing. So 7 6 3 7 6 3 2 means this is the total number of elements of order 10 is S7. Okay. So do you understand argument?
No, sir, I'm not getting the point. Sorry.
Okay. So in which part in the equation?
Which part? 10.
Yeah. Okay.
In within rectangle there are four choices.
Yes.
How four choice?
Okay.
There are no 10 cycle.
In S7, correct.
There
So
is.
yeah, since there is no single cycle of S7 in order 10, I mean of cycle length 10. So order 10 element can't come from 10 cycle, right? So
Hmm.
so next, what possible choice we can have? We can have only disjoint cycles, correct?
Hmm.
Right? Now disjoint. Now I mean yeah, disjoint cycles. So we can get a disjoint cycle such that number of total number of elements become, I mean, sum of total elements become 7, correct? I mean, there are
Hmm.
total 7 number of elements as a sum of disjoint cycles, okay? Now, since there is no 10 cycle, so first possibility is in that element there will be 1 2 cycle, right? But as long as we have 1 2 cycle in a particular element, the another choice only we have 1 7 cycle, correct? Sorry, 5 cycle, right?
Hmm.
So only one. So first possible we got is the 1 5 2 cycle, correct?
Hmm.
Now you can break it further. Let's, can 5 cycle, I mean 5 cycle, can it be broken? No. And also the 10, can it? I mean 10 can be written is only 2 into 5. Only in this way 10 can be written. Okay. So for order 10 elements, we have only one possible choice is 5 2 cycle or 2 5 cycle, but both are same because disjoint cycle we are considering. Okay. So that's why we need to only calculate the number of 5 2 cycles in S7, and this is what we have calculated.
Okay.
You understand? So just hold. Okay. Now tell me, if n greater than equal to m, then how many m cycles are there in S7? So if n greater than equal to m, then how many m cycles are there in S7? In the same way it will be done, but okay. So think about it and tell an answer. If I think about it, I shall give it some minutes.
It's NCM by M. Hello?
M choose M divided by M, right? Hello.
I think so.
Hmm.
Okay, anybody got any answer?
It's NCM by M.
Sorry, N C M.
Divided by M.
Yes, correct. Yeah, very good. Okay. So, okay, next one is a problem. Suppose the set is 1, 2, 3, dot, dot, dot. Okay. Show that the permutation group on capital A is infinite. Not say into the factorial. So the set A is the set of natural numbers. You need to show that SA is infinite. Don't give any argument like into the factorial. So you need to basically produce infinite number of distinct elements in the set S capital. Think about it. I mean, so you only need to produce infinite number of elements in it. That's the only thing you need to do. So produce infinite number of elements. That's all it is. It's easy. Just think about it. I mean, think about to get infinite number of elements only. That's all.
For every given number,
Yes.
we can form cycle of that. I mean, we can form a map. I mean, what is that?
I
Element of the
yes.
cycle.
Okay. How? I mean, how you will construct such thing? Hello. How you will construct such maps? Or I mean, such elements. I mean, you
Sorry.
can. How will you construct such elements?
So for a given number,
Yes.
for a given integer,
Yes.
you can form
Hmm.
elements of cycles with that length. So in that way, there are infinitely many elements.
Ah, yes, right, correct, very nice. So what she's told, for any integer n, we can choose n cycle. So that's infinite elements. Okay, that's all. Good. So now, thing is, suppose if n greater than equal to 3, the number of permutations in Sn, the product of disjoint two cycles is n into n minus 1 into t by 8. Thing is, if n greater than equal to 4, the number of permutation is n, which is product of disjoint two cycle is n into n minus 1. This thing, okay. So I mean, yeah, same way it can be done. Plus, but this solve it. Anybody get the answer? I mean, get the argument? Anybody? It is not difficult. It is like the previous problems. Okay, you think? Tell back of it. হ্যাঁ বলছি তুমি কোথায় আছো? কোথায় আছো? ও আচ্ছা আচ্ছা বক্তব্য হচ্ছে বাড়ি ঢোকার আগে বাড়ির পাশে তোমার জেরক্স দোকান আছে, তোমাকে একটা পিডিএফ পাঠিয়েছিল, জেরক্স করে নেবো। তোমাকে একটা পিডিএফ পাঠিয়েছি, ওই বাড়ির পাশে যে জেরক্সের দোকান আছে ওটাকে জেরক্স করে নেবো, পিডিএফ এক কপি। ঠিক আছে, পিডিএফ টেস্ট নাও। What the answer? I mean, so it's a basically so, yeah, disjoint two cycles, right? Disjoint two cycles. So like this, right? So first one can be chosen n way, second one can be chosen in n minus one way by 2 into the third one for n minus 2 choice and fourth one n minus 3 choice by 2, and then disjoints are common, that's why by 2, so n into n minus 1 into n minus 2 into n minus 3 by 8. So this is the argument. I mean, it's like the previous problem. You understand? Do you understand? Do you understand? Okay, okay. So now go to the next problem. So it's again a counting related problem. Okay. So the problem is, suppose f is a p. I mean, okay. So now consider to this type of problems. Okay. So do you know what does it mean by lattice diagram of a group? Okay, so first of all, let me tell you, make you very clear that lattice diagram of a group is something not theoretical. It's a tool for attacking some problems. Okay, Do you have any idea of lattice diagram of subgroup, or have you seen any diagram like uh, have you seen a diagram like this? Have you seen anything like this, or have you seen anything like this before? Okay, so it seems that you have not seen any diagram before. Okay, so what does my lattice diagram? Okay, so it's some kind of diagram, and it's some kind of lattice structure diagram. So on the base, I mean at the end of diagram, the identity element will be there, and at the top, the group will be there. Okay. Now, then after the group, we will consider all those subgroups whose uh, number of elements are just less than the group itself. Okay. So suppose consider S3. Okay. So for S3, if we consider these groups, cycle generator 1, 2, 3, yeah. So this cycle has how many elements? Has S3, how many 3 cycles here? Yeah, it's just 2, 3 cycles. Okay. So this is, yeah, 2, 3 cycles, and order of this group is what? Order of this group is 3 because 3 cycles. So there is a 3 order group. So just below S3, we put this 3 order group. Okay. Now S3 does not have any 3 order group, right? But S3 has 2 order groups. So the next line will be long as the previous line, and we need to put all second order groups. 1, 2, this is the one group. 2, 3, this is another group, and we need to join separate line. And 1, 3, this is another group in separate line. But then uh, observe one thing, another thing is that these 2 order groups are not inside this 3 order group. So in from this 2 order group to this 3 order group, there is no line. But every group contains the ideal element. So there is only one line. This. The thing is, the line will be like that. The top portion will contain the bottom subgroup. Okay. Then only there will be a line. Okay, that's the way. And yeah, and first the whole group, just just below that the subgroup whose order is just less than the order of that main group, and below of the subgroup we need to put all the subgroup whose order are just less than that previous subgroup, and then we go the identity. Okay. And in between there is a straight line. It means that there is no subgroups between S3 and 1, 2, okay, or 1, 3, whatever. So between any line, there will be no other subgroups, okay. So that is the lattice diagram. Do you understand?
Okay.
So can you please tell from this lattice diagram what is the normalizer of The subgroup 1, 2, 3. What is its normalizer? I mean, do you know the definition of normalizer? Do you know the definition of normalizer? So H is subgroup of G, normalizer of H contains all those G belongs to G such that G, H, G inverse equal to this is a normalizer. Okay, and normalizer is a subgroup of G. Okay, and obviously normalizer contains H. Now the question is, using this lattice diagram, can you please tell what is the normalizer? I mean, what is the normalizer of the subgroup generated by 1, 2, 3? Can you please tell? I mean, take your time. You need to use the fact that normalizer in the subgroup of G. Also, it contains a subgroup 1, 2, 3. So think about it. And anyway, without using this, you can directly can see what is the normalizer of 1, 2, 3. Please think about it.
Is it S3?
Yeah, correct. So why? I mean, these are
Since it's of order 3, it is of index 2, then H is normal.
okay. Yeah, fine,
So
fine.
therefore, it is the entire group.
Yes, it is such a normal. That's what. That's what. And so, what about this normalizer generated by the element 1, 2, which are subgroup element 1, 2? So, they here the element is 1, 2. Okay. So what is the normalizer of this group? Now, actually, for the previous one, the normalizer of 1, 2, 3 is a normal subgroup. That's why actually problem. But for the second one, normalizer of the subgroup generated 1, 2, you need to think. So, you need to consider with the lattice diagram. Okay? Because 1, 2 is not a normal subgroup. I mean, subgroup generator 1, 2 is a normal subgroup, right? So for this, you need to use the lattice diagram. I mean, without using this, possible, but the lattice diagram is a tool to solve it. So try to use the lattice diagram. Okay. Yeah, you please solve as a delta documents.
And it's again S3. It's S3 only.
Uh, so you're saying the normalizer of subgroup divided by 1, 2 is S3, right?
Yes.
So first tell me why, uh, why you think so. I mean, give the argument. Sorry. Yeah, give the argument. Why?
Because head should be, I mean, the group of 1, 2 generated by 1, 2 should be contained in normalizer of H.
Yes.
And there are no groups between S3 and the group generated by 1, 2.
Okay.
And so S3 should be the normalizer.
Okay, but the thing is, S3 should be normalized. Okay, so basically the thing is, subgroup generator 1, 2, it lies inside the normalizer and it lies inside S3. So normalizer either the subgroup generator 1, 2 or the S3, right? Correct? I mean, there are the two choices, right?
Yeah, correct.
Yeah, but just for information, S3 has no normal subgroup other than S3. Okay, I mean, this is the information you
Okay.
should have, I guess. Okay, I mean, anyway, that's not the problem. Right. So the normalizer will only be 1, 2. Okay, understand?
Okay.
Yeah. I mean, normalizer, the whole group means it's a normal sub, right? So, but that's not the case. So that's why it's normalizer is only the subgroup itself. That's the point. There was the So what is this problem? Show that S4 has no subgroup isomorphic with Q8. S4 has no subgroup isomorphic with Q8. Prove it. It's a tricky problem. Please take your time. Any idea? Okay, so first hint is that uh, okay, so assume that if H is subgroup S4, so the H is isomer of Q8, then H contains all 4 cycles. Okay, this is the thing you need to assume. Assume it now. First assume, then try to solve it. If H contains all, if H is subgroup S4 contain and H is Q8, then show that H contains all 4 cycles. Assume and please try to solve it. This is the main hint actually. Anybody got the answer or rough idea, or at least some partial way out? Any idea you got? Please tell. Please don't be silent. Okay. So the argument goes as follows. So assuming the hint, okay, first. So if H contains all four cycles, so suppose A, B, C, D is the one fourth cycle. Then its square is will be a 2 cycle. Okay. Now if H contains or four cycles, so its square, I mean a square of its element is a 2 cycle. Okay. So this implies H contains the Klein's 4 group, K4 or V4, whatever it is, right? Okay. Now, how many 4 cycles are there? 6. And how many elements in K4? 4. So, anyway, order of H is greater than equal to 10. That's the contradiction. So, that's why it can't have any subgroup of order 8, I mean, which is isomorphic Q8. Okay. So, first, let me do the argument. So, if we assume that any subgroup of S4, which is isomorphic S4, can contain all the subgroup, all the 4 cycles, then if we do square of all 4 cycles, we will get a 2 cycles. Okay. So this tells that an a order of 2 cycles is 2. Okay. So this tells that H contains all 2 cycles. This implies H contains the Klein's 4 group of a S4. Klein's 4 subgroup inside S4. Okay. So order of H is greater than equal to 6 plus 4. So greater than 10. So that's why H. So order of H is greater than equal to 10. Okay. That's the that's the argument. So now all you need to check H contains all four cycles. Okay. How to do it? So Q8 its element are what? Plus minus 1, plus minus I, plus minus j, plus minus k. Okay. So order of I, order of j, order of k. These orders are already 4. Okay. So this consists of 4 cycles. Okay. Now consider the element ij, jk, kl. Order of these elements are also 4. You can calculate it by using the definition. So Q contains all the 4 cycles. So that's why, that's why the whole argument. Do you understand?
Hello, sir.
Yes, that's it.
Sir, I have one doubt.
Yes.
H contains C for you have written in the above.
Sorry, can you just repeat?
One more time explain, please.
Oh, yeah, sure. So first, assume the hint that if H is above S4, which contains which is isomorphic Q8, then H contains all 4 cycles. Okay, first assume this. Okay. Now, out Now, for example, you can take any 4th cycle in S4 and take the square, then you will get a 2-2 cycle. Okay, so basically, since H contains all 4 cycles, so you will get all possible 2-2 cycles of S4 inside capital H. Okay, so now collection of all 2-2 cycles along with the identity element is subgroup of S4, namely the Klein sport subgroup. Okay, and whose order is 4. Okay, so the number of elements is of 8 is at least 6 plus 4, which is 10. So H is isomorphic to 8, but order of H is greater than or equal to 10. So that's the contradiction. The main trick is, if we take any 4 cycle and we take the square of that element, we will get a 2-2 cycle. Okay. Now since H contains all 2-2 cycles, so H contains the Klein sport group along with all 4 cycles. So that's the order of H is greater than or equal to 10. That's the contradiction. You understand? You understand? You want to please let me know? Okay, I hope that you understood. So, but just tell me one thing. Do you know the definition of field? Anybody know the definition of field?
Yes, sir, I know.
Okay. Okay, so forget field, consider ZP by P is a prime. Okay. So can anybody, can you please calculate the number of elements in GL and ZP? How many elements are there in GL and ZP? So GL and ZP contains all matrices over ZP whose determinant is not equal to 0. Okay? So basically, we need to consider all matrices whose rows are not linearly dependent. Okay. So how many possible matrices are there over the field ZP? Let's calculate. It's obviously a counting problem, and this problem can be. After this we can, if time permits, there is a problem which connected with this in the direction of combination group. So that's the first calculate the number of elements in GL and ZP. Please take with that. Please solve it. need to calculate how many. You need to calculate how many linearly independent rows over ZP are there of column size smaller. That's what the thing you need to calculate. Oh, okay. So the idea goes as follows. So GLM, right? It's an n cross n matrix. So first column, second column, and then total n columns up there. Okay, and each column has n entries. Okay. Now the first column can't be zero, right? So first column is n entries. So we have q to the power n choice, but none of the element can't be zero. Okay. So that's why first column can be chosen in q to the power n minus 1 ways. Let me repeat. Each element can be chosen in q ways. So q ways, okay. So yeah, sorry. So the thing is, so suppose A, B, C, dot dot dot, Y. Okay. Now this column can't be 0, 0, 0 like this. Okay. So that's why first column can be chosen q to the n minus 1. What about the second column? Second column can be chosen, each element can be chosen in keywords minus. Second column can't be a linear combination. I mean, can be linear. Second column can't be a multiple of the first column. So second column C2 can't be some lambda times C1. So this lambda can be chosen q ways. So second column can be chosen q to the power n minus q ways. Third column, each element can be chosen q ways. So total q to the power n minus. Third column, so third column C3 cannot be linear combination of C2 and cannot be linear combination of C1. So minus this element can be chosen q ways, this element can be chosen in another q ways. So q square. Dot dot last element q to the power n minus q to the power n into q to n minus 1 is okay. This is the argument. So there's a total number of elements in GLN ZP. Yeah. So do you understand the whole argument? Please let me know. Oh, sorry, I suddenly, I mean, now I can see some group chats there, but sorry, I mean, while over the screen it is not visible, that's why I could not see some chats over there. Sorry.
Sir, P power n or Q power n?
Sorry, can you please repeat?
Sir, you are written Q power n. But given is that P.
Oh, sorry. Okay, so I mean, sorry, I mean, that P or Q, whatever PQ or prime. I mean, it should be P. Sorry. Question in the book is written in the book. The question is written as Q, so I forgot it. Sorry. So that's P to the n minus one, P to the n minus P2. Okay, yeah. Sorry.
Sir, can you explain first term only?
Yes, sure. So first
P power
column,
n.
yeah, first column has P entries. Okay, so first column can be chosen in P to the power n ways, but first column can't be 0. So that's why P to the power n minus 1, P to the power n minus 1. In this way, we can choose the first column. Understand?
Sir, how P power n occurs?
Because first column has P entries, right? Sorry, first column has n entries and each entry can be chosen in P ways. So first column total entries, I mean all n entries can be chosen in P to the power n ways. But since it's an element of GLN, so the first column can't be 0 itself. That's why P to the power n minus 1 number of choices we have for the first column. Understand? I mean, yeah. So first column has n entries, so each entry can. I'm
Now I
sorry.
understand.
Okay. So okay, can anybody? It's not a possibly this last problem. S3 is isomorphic to D6. Can anybody tell why this is so? I mean, obviously, this means that you need to show an extra isomorphism. But the thing is, S3 isomorphic D6, you can show it by saying that S3 has X order of X number of elements of order Y, and same D6 has X number of elements of order Z. I mean, you can give the argument like S3 has this number of elements of order this, and similar D6 has like this. So, I mean, or you can give another. I mean, no need to give explicit isomorphism. Okay. So give some intuitive idea. I mean, give some idea why S3 isomorphic to D6. Give some idea why S3 isomorphic D6. Or you know the generator of S3 generator of D6. You can give the argument in that way also. Think about it.
Both are non-abelian.
I mean, there are many non-linear groups, right? So you give something more, right? I mean, you can give one way that S3 has this number of element order this, or D6 has this number of element order this. That argument will only work, but only non-abelian will not work, obviously, correct? Yeah, or you can also say that any non-abelian group order 6, any two non-abelian order 6 isomorphic you can use this argument also, but if you think so, then give the whole argument.
S3 has two element order 2. The
S3 has S3 has three elements of, sorry, what is
three three elements there's order 2,
Yes.
and two elements order 3.
Hmm. Yes, then what about this? What about D6?
D6. Yeah, I could not.
Okay, the thing is that do you know the generators of D6? I mean, yeah, do you know the generator of D6?
Sorry, sir, I don't know.
Yeah, okay, so basically D6 is generated by R comma S, where R cube is equal to 1 is equal to S square and RS is equal to SR inverse. This is the relation. This is the relation, okay? Now in S3 we almost have same thing. You need to identify which we should take as R in S3 and which we should take as S in S3, okay? So that's the thing you need to consider. So basically, uh, if we take A is equal to 1, 2, 3 and B is equal to 1, 2, then A cube is equal to 1 is equal to B square and BA is equal to A inverse B. Okay. So yeah. So basically you can assign A with R and assign B with S. That's what the thing is. Understand? You understand?
Yes, sir.
Okay, so it's almost 9, I guess. Okay, so let's stop here first. Okay, so you can see in the chat that I've shared one link for the attendance purpose. Please share your attendance. Please give your attendance by submitting the Google form. Please give your attendance.
Sir,
Yeah, sure.
I have one doubt, sir, from previous the example.
Sorry, I didn't get it. What? Sorry.
I think order of general linear curve.
Can you please write in the chat possibly your network issue? I could not hear you properly. Please write in the chat.
GLN of ZP.
Oh,
Suppose
yeah. Please go.
suppose take P is equal to 2, then
Yeah, but the thing is that this argument works for NEP and NEM. Okay, so you take a column. This column has small n entries. Okay, and each entry can be chosen in p ways. So the total number of ways of for a column can be chosen p to the power n. Now the thing is that column can't be full zero. So that's why p to the power n minus 1. In this number of ways, we can choose the first column itself. Understand?
so I could not think like you, sir, but I try to think.
No, wait. So in a first column, we have n entries. Okay, correct? And we are in the fit ZP. So each entry can be chosen in P ways, correct?
Yes, sir. But people, then P power n ways.
Yeah, so total P to the power n ways, right?
Yes.
But this full column can't be 0, 0, 0, right? It can't be whole 0. So that's a P to the power n minus 1. Understand?
Yes, sir. Yes, sir.
Yeah.
Okay, sir. I will learn. Thank you, sir.
Okay, so I hope everybody gave his or her hands. So yeah, so let's stop here. We'll meet on the next Friday. So I'm leaving the call. Thank you.